The next thing that we want to look at is a closer examination of slope. This comes from section 3.3. In order to do this section, you need to know how to plug in and simplify expressions involving multiple variables. You also want to be able to understand how to add, subtract, and divide signed numbers. Upon completing this presentation, you will be able to calculate the slope given 2 points, understand how the slope affects the visual representation of the line, understand how slope relates to parallel and perpendicular lines. So when we talk about slope, we've talked about it being rise over run. I think I also mentioned that it's the ratio of the vertical change to the horizontal change. And so finally, the last definition that we're going to use for slope is the actual formula. So the formula for slope is m equals y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are points on the line. We've seen subscripts before when we looked at solving equations for indicated variables. And now we're going to see kind of another example of subscripts in mathematics. And so the subscripts for each one of these is basically x1 means the x-coordinate of the first point. y1 means the y-coordinate of the first point. Similarly, for x2 and y2, these are the x-coordinates and the y-coordinate of the second point. So our procedure in order to determine the slope of a line given 2 points, our first step, we want to label the coordinates in each point with their corresponding variable and subscript. From there, we want to plug into the formula, simplify using order of operations, and finally, write your answer as a simplified fraction or whole number. Since we are not graphing, it is okay to write the answer as a whole number because we do not necessarily need to know the rise and run for the slope. Make sure that when you do this, you write it as a simplified fraction. Do not write as a mixed number. So let's talk about what are some examples of lines. What are the different visual pictures that we've seen so far? The first one is an increasing line. An increasing line is a line that goes up from left to right. And in terms of the slope, what we have is it has a positive slope. Our second type of line is a line that goes down from left to right. This is known as a decreasing line. A decreasing line has a negative slope. And then if you recall, we had 2 special cases. The first special case was a horizontal line. This is a line that stays at the same height from left to right. It does not go up or down. And a horizontal line has a 0 slope. Finally, we had a vertical line. A vertical line is a line that goes up and down, but never left to right, and it has an undefined slope. Undefined, remember, is another phrase for cannot be done. And so when you think about horizontal and vertical lines, can you walk on a horizontal surface, like the floor? Yes, you can. Can you walk up the wall? Well, unless you're Spider-Man, the answer is no. So vertical lines, like the walls, are going to be the ones that are undefined, whereas horizontal lines, flat surfaces, are going to be the ones that are equal to 0. So let's go ahead and look at some examples and see what we can do. We're going to be doing 2 things. We want to calculate the slope, And we also want to go ahead and determine if it is increasing, decreasing, horizontal, or vertical. So the first thing that I want to do when I work on these problems is I want to go ahead and start by writing down my formula for slope. If you struggle to remember things, then this is something that helps out. Just get in the habit of writing it down so that you have it available there for you. And the more you write it down, the more comfortable you are going to be with it, as well as the more likely you are to memorize it. So, my formula for slope is m equals y2 minus y1 over x2 minus x1. I'm going to go ahead and label the coordinates of my points. So my first point, I'm going to label this x1, y1. Remember that the first number is the x-coordinate, the second coordinate is the y-coordinate. Similarly, on the second one, I'm going to label the first coordinate x2 and the second coordinate y2. So now that we have this, we can go ahead and plug in to our formula. So for our formula, we get y2, which is 4, minus y1, which is negative 1. So be very careful here that you remember this is minus negative 1. On the bottom, we have x2. x2 was negative 2 minus x1, which is negative 3. So as I mentioned on the first slide, we do need to remember how to work with these positives and negatives. So the first thing that I want to do is I need to change my minus and negatives into pluses. So this becomes 4 plus 1, which is equal to 5 over. Same thing, the minus negative 3, I want to change this to plus a positive 3. And so negative 2 plus 3 is positive 1. We do have different signs. We want to subtract, keep the sign of the larger number. From here, we want to go ahead and simplify the fraction. Remember that we are allowed to write our slope as a whole number since we're not graphing. And so my slope is 5. Finally, I want to know, is this line increasing, decreasing, horizontal, or vertical? Since 5 is positive, this is an increasing line. And that takes care of example A. Let's go ahead and look at example B now. Example B, again, I'm going to start by writing out my formula. So we get m equals y2 minus y1 over x2 minus x1. If we go ahead and label the first point, I'm going to label this x1, y1. The second point, I'm going to go ahead and label this x2, y2. So now when I go ahead and plug in, I get y2 is negative 2 minus y1, which is 4, over x2, 2, minus x1, which is negative 3. From here, we want to go ahead and simplify the numerator and the denominator. -2 minus 4, we have same signs, so we are going to add and keep the sign. On the denominator, we want to change this to plus +3, and 2 plus 3 is 5. Can we simplify the fraction? This one cannot be simplified. The only thing that we could do is convert it to a mixed number, but we don't want to do that. So we're going to leave it as just -6 over 5. So now, is this increasing, decreasing, horizontal, or vertical? Well, since we have a negative slope, this is going to be a decreasing line. This will go down from left to right. And we're done.
Let's now look at example C. So example C, again, I'm going to start by writing out my formula and labeling my points. So my formula is m equals y2 minus y1 over x2 minus x1. If we label our points, I'm going to call the first one x1, y1. Second one is going to be x2, y2. And so now if we plug in, we get y2, 4, minus y1, which is also 4. So the numerator will be 4 minus 4. The denominator, we want to subtract our x values, so we get 3 minus 5. And now if we simplify, we get 4 minus 4 is 0. 3 minus 5 is -2. And we should go ahead and simplify this down to 0. Remember that if it's 0 divided by a number, that's allowed. So we get a slope of 0. So now looking at our slope, we can see that this is not going to be an increasing line. It doesn't have a positive slope. It's not going to be decreasing either. It's not negative, which means that this is a horizontal or a vertical line. So remember that 0, you are allowed to have a slope of 0. This is like walking on the ground, walking across the floor. 0 slope, you can do that. It is a number. So this is a horizontal line. Also, another way to look at this is notice that for both of these points, we have that our y-coordinates are both 4. Since our y-coordinates are both 4, what this says is I am moving to the right and left, but my y values are staying the same, which means that my line is going to be at the same y coordinate all the way across, which means that it will be a horizontal line. All right, so now let's look at the final example. Our final example, we have 2, 5, and 2, 1. So starting with our formula again, we have m equals y2 minus y1 over x2 minus x1. If we go ahead and label our points now, we have x1, y1, x2, y2. And now if we plug in, we end up with x2 minus x1 is going to be 1 minus 5. And x2 minus x1 will be 2 minus 2. If we simplify this, we get 1 minus 5 is -4 over 0. And recall that you, in order to simplify this, can you divide by 0? Can you have a denominator of 0? And the answer is no, which means that this is the one where we have an undefined slope. Also, if you look at your points, we have 2, 5, and 2, 1. My x-coordinates are the same. And so what I'm doing is I am just moving up and down vertically. This is similar to our wall problem. Remember that you are not allowed to walk up the wall unless you're Spider-Man. And even then, he's really crawling. And so this is the example where we have an undefined slope. This is a vertical line. And we're done. So those are some basic examples of finding slope and interpreting what our line looks like. Now, one thing I do want to point out on each one of these is, does it matter which point you label as x1, y1, and x2, y2? When it comes down to it, it does not. I'll explain later why we do the second point minus the first point, but one thing to note is, depending on what your numbers are, you may want to go with a similar formula, which is y1 minus y2 over x1 minus x2. It doesn't matter, as long as you are consistent in the numerator as you are in the denominator in terms of the order that you are putting them in, it does not matter. So let's go ahead and show this on one of them, just to show that we will still get the same answer. So if we look at example A again, let's go ahead and plug in y1 minus y2. If we do this, we get -1 minus 4. Over, now if we do x1 minus x2, we get -3 minus -2. We can go ahead and change this to a +2. Minus a negative becomes plus a positive. And now we end up with -5 over, we're going to subtract 3 and 2, we get 1. We keep the sign of the larger number, it's -1. And now we see that -5 over -1, you should be able to divide that out. And note that it is still the same answer. It is still 5. So this is kind of going back to that idea about when we talked about graphing in terms of going up and to the left or down and to the right. You have to do opposites, depending on which direction you're going in the line. Same thing when you use your slope formula. So what's the point of this? So the point of this is that, for instance, if you struggle with subtracting negatives, we may not want to set it up the way that we did originally. If you get an answer that doesn't make sense, you can always flip the numbers around and make sure that it does come out to be the same answer. But as I said, the main thing that you want to keep in mind when doing this is your y's have to go on top, your x's have to go on bottom, and these subscripts need to be the same. Right there, as well as right over here. Notice that it has to be the same in the numerator. Whatever you're doing in the numerator, you have to do in the denominator. The difference is just which coordinate are you going to be working with. Okay, so hopefully that makes a little bit more sense.